Welcome to Eureka Math. I'm Mr. Schenkel. I'm going to be helping you today with the Module 4A review. Let's get started. All right, writing expressions from a word phrase. We have to write whatever we see that's happening here, and we talked about this in class. The first thing I see is the word increased. Increased tells me that it is going to be an addition problem. So this is going to be 5 plus k. And if you wrote k plus 5, that works too, because addition is commutative. Doesn't matter the order that we add. We get the same answer. Okay, the next one, number 14, n less than 7. In order to get less than 7, we have to start with 7 and take n away. N less than 7 should be 7 minus n. All right, number 15, 12 multiplied by s. 12 multiplied by s we can write as 12s. Remember, we don't need a multiplication symbol if it's a coefficient right next to a variable. And then number 16, you should have had the sum of, well, as soon as I see the sum of, I know it's going to be an addition problem. And remember, the addition problem is where the addition sign is where the and is in your phrase. So this is 4 plus twice d means 2 times d. So 4 plus 2 times d would be that expression. All right, next, write a word phrase for each expression. Lots of things you could do. You could just do 8 times 8 times y, or you could say the product of 8 and y. A few ways you could do that. 8 multiplied by y, etc. 18. Some things that it could be, you could just say 9 times x, comma, minus 5. That would work. You could say the difference of 9 times x and 5. You could say 5 less than the product of 9 and x. So lots of ways that you could write a word phrase for that expression. There's a couple of examples. 19. Identify the coefficients in the following expression. Well, coefficients are the numbers attached to variables. So the coefficients would be that 3 would be a coefficient. The 4 attached to the x would be a coefficient. And there's actually a 1 in front of that a. So that's also a coefficient. The 6 is not. This 6 would be a constant. The negative 6 would be a constant, not a coefficient. So the coefficients in that expression are 3, 4, and 1. Number 20. You had to find the variables in the expression. Well, variables are letters. So x is a variable. Y is a variable, and H is a variable in that expression. All right, the last thing we have to do here is we have to identify the part of the algebraic expression that's underlined. Well, the 6x together is called a term. And there are 3 terms in this expression. The 4y is a term, the 6x is a term, the plus 7 is a term. And there are terms in every one of these expressions. But the 6x that's underlined in this one is called a term. The next one is just the number that's attached to the variable, that 8, and that is called a coefficient. Coefficient is that one. And then lastly, we have just the 5 out here all by itself, not attached to a variable. It's a 5 no matter what. We call that a constant. That one's a constant. You're going to need to know those for the test. There's not much more I can ask you on this part of the test, so this is kind of it. If you know what those terms are, you should be okay. Okay, next. Write an equivalent expression for each expression. Here's where I want to write this as efficiently as possible. So this is like sorting baseball cards. I've got one X here and another X there. That's a total of 2X. Plus, I've got some Y's. So the Y's here, I've got one Y there, and plus another Y, that's 2Y, and that's another Y, so that's 3Y. And there's another one, so that's 4Y. So 2X plus 4Y. And then I can't add these together because, well, this is an X, and the other one is a Y, so they're different variables. Can't add them together. So this is as good as I can get for that expression, 2X plus 4Y. All right, so what we showed here was repeated addition, and in the next one, number 23, we have repeated multiplication. So this is different. Repeated multiplication is an exponent. So what I'm going to use is the number that's being repeatedly multiplied. In this case, it's the variable v. And then the exponent is going to tell me, this exponent is going to tell me how many v's am I multiplying together. So if I just count them, 1, 2, 3, 4, 5, 6, there are 6 v's multiplied together. So this is v to the 6th power. And what you have to remember is repeated multiplication is an exponent, and repeated addition is multiplication. Okay, next. We have to use the distributive property to create an equivalent expression. And this is where we talked about it on Friday. It's like delivering the newspaper to all of the houses in the neighborhood. This is where I would take this expression, and I like to draw arrows in there so I can really see what's going on. This is 4 times 9, so 4 times 9 is 36, plus 4 times 2x, well that's 4 times 2 is 8, and then the x, 4 times 2 is 8x. So 36 plus 8x is my new expression that's equivalent to 4 times the quantity 9 plus 2x. All right, number 25, I'm going to do the same thing. I'm going to rewrite this, 5 times the quantity y plus 4x, and then I'm going to distribute the 5. I'm going to deliver this newspaper. The 5 goes to the y, and that's a 5 times y, 5y. And then this 5 goes to the 4x. 5 times 4x is 20x. And remember, I can't add these together because this one's an x and that one's a y. Different teams can't add them together. All right, number 26, 27, and 28, we're going to factor out the common factor. So this is where we made a tree. 5 times g is, or 5g is 5 times g. 5's prime and g is, can't break that down, so that's it. And then if I broke down 5 and 5y, that would be 5 times y. And I can see that I have a common 5. So 5 is my GCF, and whatever's left in my two trees is what's left in my sum. So I can see that there's a G left here plus a Y that's left over here. So 5 times the quantity G plus Y is my answer. All right, that's an equivalent expression. Let's try number 27. I'm going to break down 8h into, well, this is 8 times h, and then 8 I can split into 2 times 4, and then 4 I can split into 2 times 2. So there's my prime factorization of 8h, and then 4 would be, well, 4 is 2 times 2. So I see this 2 matches with that 2, and this 2 matches with this 2. And if I look at just one of the trees, I can see that My GCF is 2 times 2, which is 4. So 4 is my GCF. And then whatever's left in my trees is what's left in my sum. So I have a 2 and an H in the first term. And there's nothing left here. So you might think 0, but it's actually a 1 because 4 divided by 4 is 1. So 4 times the quantity 2H plus 1 is the answer for number 27. Okay, here's number 28. Let's see, I've got 12F, which I can break into 12 times F. And then F is kind of like prime. There's nothing I can do with that. So 12 I can break into 2 times 6. And 6 I can break into 2 times 3. So there's 12F. And then 8B, well, that's 8 times B. And 8 I can break into 2 times 4. And 4 I can break into 2 times 2. So now I look for what's common. I see this 2 matches that 2. I see another 2 here matches another 2 there. And that 6 is gone, so that's it. So my GCF is, if I look at one of the trees, doesn't matter which one, multiply the circles back together, my GCF is 4. And then whatever's left in each tree, 3F is my first term, 3F, plus whatever's left in my second is a 2B, and that's the last term in my sum. So 4 times the quantity, 3F plus 2B is how we would factor that one. Okay, lastly, we have to decide if these 3 expressions are equivalent. And the way to do that is to just use the distributive property and to combine like terms until they all look the same. So what I'm going to try to do is make all of the expressions look like this one: a coefficient multiplied by a variable plus a constant. And I can do that by distributing. 4 times P is 4P, plus 4 times 8 is 32. And right away I can see that they're not the same. So 4P plus 8 is not the same as 4P plus 32. And then over here I could take this 3P plus 1P, that's 4P. I can add those together because they're on the same team. And then plus 8. And the first and the third are the same, but the second one is not the same. So all 3 expressions are not equivalent, and I know by using the distributive property. All right, more review tomorrow. Test will be on Wednesday. Hope that helps, and I'll see you then.